Okay, so in this lecture, I'm going to introduce synthetic division, which is what we've been building toward to solve these higher polynomials. We've discussed factoring, and then you have to think about what happens if factoring doesn't necessarily work. If it's a polynomial that you don't know how to factor, like how am I going to find the zeros? Of course, without a calculator, because in college algebra you don't have the nifty graphing calculator, so this is a skill that you have to know. So I start nice and easy with something that you probably vaguely remember from Algebra 1, which is dividing by a monomial. Now when we divide by a monomial, this is rather easy. It's basically just like GCFing it out. So remember that when we divide by a monomial, it's the same as this kind of theory. Everything gets divided by 3x squared and we simplify. Okay, so we're taking into account that the polynomial is divisible by the monomial, and then we just factor. So 6 divided by 3, divide. So 6 divided by 3 is 2. X to the 4th divided by x squared is x squared. 15 divided by 3 is negative 5. X squared divided by x squared is 1, which is just 5. And then 3x squared divided by 3x squared is 1. So then we have 2x squared minus 4. Okay, so just regular division. So same thing, 21a to the 5th b cubed over 7ab minus 14a cubed b squared over 7ab plus 63a squared b over 7ab. And we do the same thing. 21 divided by 7 is 3. A to the 5th divided by a is a to the 4th. B cubed divided by b is b squared. Negative 14 divided by 7 is negative 2. A cubed divided by a is a squared. B squared divided by b is b. 63 divided by 7 is 9. A squared divided by a is a. And b divided by b is 1. Okay? So this really is more simplifying than true division, like what we think about when we think true division. Now it is division, but you probably tackled this more like a simplifying problem in Algebra 1. Okay? So let's look. So what happens when we divide by a binomial? Okay, so it's all fine and good with this one because I know that this factors into w minus 5, w minus 2 over w minus 5, and then we break out those rational equation or rational expression skills and know that these cross out and leave me with w minus 2, right? Same here, we can rewrite this h squared minus 7h minus 8. So h minus 8, h plus 1, divide by 4. And we get h minus 2 and 4h plus 1. So that gives me 4h plus 1, h minus 2 divided by h minus 2. So just rewrite it as a fraction division. And again, rational expressions take hold. Anything over itself is 1 and leaves me with 4h plus 1. Okay, so those are rational expressions, something we've already tackled at this point. So then the question becomes, well, what do we do if factoring isn't possible? So the first thing that you ever learn way back, if you'll remember, is like long division. So you do 2 into 324, right? 2 into 3 is 1. Bring down the 2. 2 into 12 is 6. Bring down the 4. And 2 goes into 4 twice, right? Long division. It works exactly the same way with polynomials. So we have x plus 8 into x squared plus 3x minus 43. Now we know that when we multiply a binomial by something, we have to multiply everything in the binomial by that. So I'm going to look at these two terms first. So how do I get from x to x squared? Well, I multiply by x. X times x is x squared, exactly what I was trying to do. But we know that we can't just multiply it by that x. We have to multiply the 8 by x too, which gives me 8x. And just like we did over here, we're going to subtract. Okay? So that goes away as we anticipated. And 3x minus 8x is negative 5x. And then we bring down the next term, negative 43. So then the question becomes, how do I go from x to negative 5x? Well, multiply by negative 5, right? So I have negative 5x minus 40. and then we subtract. And as we anticipated, that goes away. We have negative 43 minus a negative 40, which would be a negative 3. And that's my remainder of 3. So many, many moons ago, when you first learned division, you learned remainder of 3. And so like if you had 2 into 17, right? You first learned that 2 times 8 is 16. Let's leave me with 1, and you would write remainder 1, right? Like, I don't know, when you first started division, 3rd, 4th grade, whatever. Okay, and then after that, you learned that you would say that was 8 and 1 over 2, the remainder over the divisor, right? And then you learned to add a decimal and add a 0 and then keep going, that this is equivalent to 8.5, right? So this can be written like this with a remainder of, negative 3. This can also be written as x minus 5 minus 3 over the divisor, which is x plus 8. Okay? Just to kind of bear that in mind, it's coming for you. Okay? Then someone very, very smart came up with synthetic division, which is a lifesaver. Okay? Synthetic division, we draw a little box and we draw a little line. Okay? In this box goes the opposite of what's here. It's the 0. So x plus 8 is the factor. My 0 is negative 8. So my 0 goes here. And then the coefficients of my dividend, which is what I'm dividing, go here. So 1, 3, and negative 43. Okay? The first thing we always do with synthetic division is drop the first term. Okay? Then we multiply. Negative 8 times 1 is negative 8. And then we add. 3 plus a negative 8 is negative 5. Multiply. Negative 8 times negative 5 is positive 40. And then we add, and we get negative 3. The last number is always your remainder. Notice we have the same numbers. Okay? So, just like here, this was a quadratic. If I factor out an x, then I'm left with, if I factor out one x, then I'm left with just an x. The same thing here. If this is an x squared, then this is just an x. So this would be x minus 5 minus my remainder over my divisor. Okay? So use synthetic or long division. So we're going to use synthetic because that's what we're working towards. So the catch with synthetic is that your dividend has to, your divisor always has to be in this form. No coefficient, just like this. So we're going to put the opposite in our box, our 0, so a positive 7, not a negative 7, and the coefficients across the top. So 2, negative 16, and 19. So I'm going to drop the first term. 7 times 2 is 14. Add, okay, negative 2, multiply, negative 14, and add positive 5. So that's my remainder. So this would be drop by 1 degree. So it started as a quadratic. So drop by 1 degree. So this is an x. So we have 2x minus 2 plus 5 over, oh, it's not an x, sorry. 2n minus 2 plus 5 over n minus 7. Okay. Number 8. So I'm going to do my box. The opposite goes into my box, 2. Coefficients across the top. So 1, 5, negative 7, positive 2. Drop the first term. Multiply. 2 times 1 is 2. Add 7. Multiply 14. Add 7. Multiply 14. Add 16. The last number is always your remainder. So if this was a cube, if I take one x out, then this is a squared. So I have x squared plus 7x plus 7 plus my remainder, 16 over x minus 2. It's supposed to be a y. Sorry. Okay. If this number, when you write out your polynomial, is not a constant, something is wrong, because your last number should always be your remainder. Okay? So notice here it says, what do we do if we have a missing power in the dividend? Okay, we have to put a placeholder there. So in my box goes the opposite, so -5. So notice I have a 3, I'm missing a squared term, and then I have a 1. So I'm going to put 1 for my k cubed, 0 for my k squared, -17 for my k, and 32 for my constant. Drop the first term. Multiply, -5, add, -5. Multiply, 25. Okay, then we add. Multiply, and then add. Okay, now this is a k cubed, so this is a k squared. So I have k squared, 1, understood, minus 5k plus 8. Notice my last number before my remainder is always a constant, minus 8 over k plus 5. Okay? So same thing. First thing I always check, 4, 3, I'm missing a 2, a 1, and then 0. So opposite goes in my box. So I have an 8. Coefficients across the top, 4, 3, and I'm missing 2, so I put a 0, 1, and then no variable. Drop the first term. So 8 times 8 is 64. Add. 8 times 0 is 0. Add. 8 times 0 is 0. Add. 8 times 3 is 24. And we get -4 as the remainder. Okay, so if this is a 4th degree, if I take 1x away, then this is a 3rd degree. So I have 8x cubed plus 0x squared plus 0x plus 3 minus 4 over my divisor. But now we know, since the history of forever, we don't have to write zeros. So this would just be 8x cubed plus 3 minus 4 over 8 minus x. Okay? All right. So the first two things we're going to talk about using synthetic division for are these two basic theorems. The first is the remainder theorem. The remainder theorem says that basically when you do synthetic division, that whatever the remainder is the value of the function at that number. Okay, so it says use remainder theorem to find p of -5 for this polynomial. So -5 goes in my box because remember it's the 0. Okay, -5 is the 0, is the value of x, not the factor. So 4, 3, 2, 1, 0. So 1, 3, -8, 5, -6. I have 1. So bring the first one down, multiply, add, multiply, add, multiply, add, multiply, add. So how we would write this is we would say that p of -5 is equal to 21. So this is how your answer should look if the problem says use remainder theorem to find the value of the function. Okay? So just to kind of quell what you might be thinking, let's go here to the calculator, which I should have already had pulled up. I apologize. Okay, and let's put in our problem. Okay, so I'm going to go to y equals, just because it's easier for me to do y equals than to type it 47,000 times, or to type a number in. I'm going to do x to the 4th plus 3x to the 3rd minus 8x squared plus 5x minus 6. And then I'm going to go to the table. And the number they wanted us to do is -5. And means my math was off somewhere. Oh, it's because I can't subtract. 25 minus 6 is 19. Sorry. And I know that you're so sad that I was not in class for you to correct me. The whole time you're thinking, where did she get 21 from? And I wasn't even there for you to correct me. So it's 19. Okay, so that's what this is saying, right? So if you look here, when you have this, that means when I plug in -5, I get out 19. That's all remainder theorem is saying, is the remainder is the value of the function at that value. The thing here is the words. If they say use remainder theorem, they don't want you to plug and chug. They want you to use synthetic division. This is huge in college algebra. Okay, so if they say remainder theorem and you plug and chug, you're getting no credit for that problem, even if you have the right answer. Okay. Factor theorem says that if we plug in a value to that little box and we do synthetic division, and our remainder is 0, then it's a factor. Now we know this because we know that when we set our factors, like if we have a factor of x plus 1 and x plus 2 equals 0, and we say x plus 1 is 0, x plus 2 is 0, so x is -1 and -2. We know that that factor is a 0. That by definition is what it means. Now if you think back, how do I know that 2 is a factor of 8 and not a factor of 9? Just basic math, like 3rd grade math. Well, you know, because it goes into it evenly, right? Meaning there is what? No remainder, right? A remainder of 0, okay? So this has a remainder of 1, this has a remainder of 0, so I know it's a factor. It's the same exact philosophy here. Okay, same rules. Rules don't change. The problems just get more complex the older you get, right? So the way you answer this problem is important. So like we talked about here, if they say use remainder theorem, this is what your final answer should look like. P of -5 is equal to 19. Okay, so for factor theorem, it's a little bit different. The work is the same, but just your answer is different. So I'm going to plug in the opposite because it gives me a factor. So 2. So 4, 3, 2, 1, 0. First thing I always check. So 1, 1, -10. -4 and 24. So first thing is always bring the first one down. Multiply. 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. Add. Multiply. Add. Multiply. So I have a remainder of 0. So yes, x minus 2, we can just put yes, it is a factor because the remainder is equal to 0. Okay. Letter B. Again, we put in the opposite. So -1, 1, 1, -10, -4, 24, 1. So multiply, add, multiply, add, multiply, add, multiply. So clearly this has a remainder that's not 0, so no, it is not a factor because r does not equal 0. Easy as that. Okay? The boundedness theorem we're going to briefly touch on, and then we'll come back to it a little bit later. It is something that you use in college algebra. It kind of can help you here in a little while with the Howard polynomials, but usually students find the zeros quick enough that this does not become a big issue. So if P of x, let P of x be a polynomial with real coefficients and with a positive leading coefficient. If P of x is divided synthetically by x minus c, if c is greater than 0 and all numbers in the bottom row of the synthetic division are non-negative, so when you put c in the box, so if you have a positive c in the box and all of these numbers down here are positive, okay, then this is an upper bound. It means that there's no numbers larger than c that can be a 0. Okay, so this is A. B says if c is less than 0, so if you plug in a negative number to your box and they alternate sign, okay, and it says a 0 could be considered, so that means if this was a negative, this could count as a positive, and the next one could be negative. So if they alternate, then then that letter C is a lower bound, and there's no number less than that that can be a 0. As I said, we'll come back and touch on this a little bit later. It's pretty straightforward. In college algebra, they just straight up ask you, is this number an upper bound? Is this number a lower bound? And you're looking for either all non-negatives on the bottom or alternating signs. So it's pretty straightforward. Okay, so use the boundedness theorem to determine A, if 2 is an upper bound. So I'm going to plug in 2. So 4, 3, 2, 1, 0. So 6, 7, negative 17, negative 10, 8. So remember, for an upper bound, we're looking for the entire bottom row to be all non-negative. Okay, so bring down the first, multiply, which gives me 19. 2 times 19 is 38, plus a negative 17 is 21, times 2 is 42, plus a negative 10 is 32, times 2 is 64, plus 8 is 72. So they are all positive, so yes, x equals 2 is an upper bound. Okay? So then B part says if negative 4 is a lower bound. So remember, for lower bound, we're looking for alternating signs. So bring the first number down. So 6 times negative 4 is negative 24. Negative 24 plus 7 is negative 17. So we're off to a good start. That one alternates. Negative 17 times negative 4 is a positive 68. Plus a negative 17 is 51. We're still alternating. Times a negative 4 is negative 204. Plus a negative 10 is negative 214. Times a negative 4 is 856. Plus 8 is 864. So our signs alternate. Positive, negative, positive, negative, positive. So yes, x equals negative 4 is a lower bound. And we'll talk again, like I said, a little bit later once we get to rational root theorem and you kind of understand that you have a list to pick from and how this might help you. We'll talk more about it later. But this is how they'll ask it in college algebra, just straightforward. Is this an upper bound? Is this a lower bound? Okay? All right, so students struggle with a very basic concept of how your answers should look using factor theorem and remainder theorem. Now, it doesn't matter whether you do factor theorem or remainder theorem, the synthetic division part is exactly the same. It's just the way your answer looks is actually what's different. Okay, so we're just going to do it, and we're going to do the first 8 together, and I'm going to let you do the last 2 on your own, number 9 and number 10. Okay, so I'm going to do synthetic division. So I put the opposite, so I have negative 2. 3, notice I'm missing my 2, so I put a 0, 1, and then my constant. So the first thing I do is bring the first term down, multiply, add, multiply, add, multiply, add. So factor theorem says it wants to know if this is a factor based on the remainder. So yes, it is a factor because my remainder is 0. Remainder theorem says it wants to know the value of the function. So f of negative 2 is equal to 0. Okay, so because this one is a factor, I would like to take the opportunity to go ahead and do a little practice on finding all of the zeros. So remember, if this is an x cubed, then this is an x squared, which means I have x squared minus 2x minus 6. So I have a quadratic. Okay. So I can find the zeros. So if I was finding the zero, I already have 1 here. So if I was going to use synthetic division to find all the zeros, which is what we are working toward, okay, then I would have 2 options here. This would either factor or quadratic formula. So the question is, does it factor? Okay, so if it doesn't factor, then what do we have to do? Quadratic formula. Okay, so we would just plug and chug in the quadratic formula. We're either going to get an irrational number or an imaginary number, right? Okay, so let's look at the next one. So we have factor theorem versus remainder theorem. So the work is the same. Plug in the negative or the opposite. So 5, 4, 3, 2, 1, 0. So 2, negative 5, 1, 1, negative 1, 6. So bring down the first one. Multiply, add. Multiply, add. Multiply, add. Multiply, add. Multiply, add. So factor theorem, yes. It is a factor because the remainder is equal to 0. If this was asking you remainder theorem, then we would say f of negative 1 is equal to 0. So if this is a 5th degree, then this is a 4th degree. So we don't know how to factor a 4th degree. So if we were solving this, this means we would be forced to do synthetic division again. Okay? Until we could get it down to something that we could factor. Okay, number 3. So opposite, negative 3. 3, 2, 1, 0. So 1, negative 2, negative 11, 12. 1. Negative 3 times 1 is negative 3. Negative 5. Multiply 15. So yes, because the remainder is equal to 0, which means f of negative 3 is equal to 0 if I was writing the answer for remainder theorem. Okay. So this is an x cubed, so this is an x squared. So I have x squared minus 5x plus 4. So I have x minus 4, x minus 1. So I have x is equal to 4 and x is equal to 1. So just like that, I found all the zeros. Okay, prime example. I didn't want to start you off on a quadratic formula one, but this one factors beautifully, so we'll just do that one. So number 4, did I answer the question? Yes, okay. So opposite, so negative 3 in the box, 4, 3, 2, 1, 0. So 1, negative 4, negative 1, negative 16, negative 12. So again, whether it's asking factor or remainder theorem, the work is the same. It's what you learn from the work that's different. So multiply, add, multiply, add, multiply. 1, negative 4, negative 1, negative 16, negative 12, negative 3, negative 7. Okay, negative 76. So this one is nice. So 228 plus a negative 12 is 216. So factor theorem says no, this is not a 0 because the remainder is not equal to 0. So for it to be a 0, the remainder of the output has to be 0. But for remainder theorem, this means f of negative 3 is equal to 216. So number 5, opposite. So negative 1, 4, 3, 2, 1, 0. So 1, negative 4, negative 1, negative 16, negative 12. Bring the first one down. Multiply, add, multiply, add, multiply, add, multiply, add. So no, because remainder is not equal to 0. And remainder theorem would say that f of negative 1 is equal to 8. So opposite, so 1, 3, 2, 1, 0, so 1, 1, negative 4, negative 4. So bring down the 1, 1 times 1 is 1, add, multiply, add, multiply, add. So no, because remainder is not equal to 0, and f of 1 would be equal to negative 6. So opposite, so positive 1, 3, 2, 1, 0, so 1, negative 2, negative 11, 12. 1 times 1, add, multiply, add, multiply. So it is a factor because r is equal to 0, and that means f of 1 is equal to 0. So remember, if this is a cubed, then this is a square. So I have x squared minus x minus 12 is equal to 0. So x minus 4 and x plus 3 is equal to 0. So I have x is equal to 4, x is equal to negative 3. So I have 3 zeros, 1, 2, and the one given, 3, right? Okay, number 8, opposite, so negative 2, 3, 2, 1, 0, so 8, negative 2, negative 41, and negative 10. Multiply, add, multiply, so negative 18 times negative 2. 36, add a negative 41, it's negative 5, a positive 10, gives me a remainder of 0. So yes, because the remainder is equal to 0, and remainder theorem means f of negative 2 is equal to 0. Okay? All right, so the first thing that I want you to do is finish number 9 and number 10. Number 9, I only want you to do factor theorem, and I want you to find all the zeros like we did. I'm telling you it should work out that the remainder is 0, and then I want you to factor and find all the zeros. Number 10, I want you to work it as remainder theorem because it does have a remainder, and I want you to give the appropriate answer. Okay, and that is attached in the PDF file on Google Classroom. I also want you to complete handout number 1, which is also attached in the PDF file on Google Classroom has the handout and the answer key, how that one, I want that worked. And there's also a practice quiz on factoring. It's just factoring. This is good additional practice for the factoring that it would just be a good idea to practice. Okay.